Imagine trying to stop a bus from 160 miles per hour on a very wet road. Most of Bloodhound's very high-speed braking will be done using air brakes, but it will be the wheel brakes that ensure the car stops in exactly the right position by the support crew who will ready the car for the return run.
Our brakes are unusual because they've got to survive at 10,000 RPM, but we only use them from 160 miles an hour downwards. So initially we tried using these carbon rotors that were off a fighter aircraft, but unfortunately they wouldn't survive above about 5,000 RPM. And as you can see, we have some of the results of the failed discs here. This is a runway disc for the Bloodhound car, but the desert discs are a similar size, and as you can see, they're quite large and they're quite difficult to package in the front of the car. We try and keep everything as narrow as we can, and as a result, the front upright on the car has ended up having the caliper actually built into the upright. Because the wheels have very little grip on the desert surface, we can't use the brakes to their full potential, and as a consequence it takes us a lot longer to stop than you would with a normal car, and it's a bit like trying to stop on a very wet road.
It was decided that steel would be the most suitable material for the discs, but they would need testing to make sure they didn't warp or become brittle at extreme temperatures. AP Racing's test rig uses a huge flywheel to simulate the weight of the car, and at over 6 tons, Bloodhound would push it to its limits. 4.6 kilowatts of energy was scrubbed off in just 19 seconds. Although the disc surface reached temperatures of over 850 degrees centigrade, it performed perfectly and could be used several more times. The next test will be to see if they can survive the 10,000 RPM spin test that destroyed the carbon discs.